Hello everybody. Today we will evaluate these two improper integrals, but we won't evaluate them separately. Okay, we'll see how we do it. Okay, first of all, since these are improper integrals, let's see if they are convergent or not. Okay, e to the power minus ax, a is given to be greater than 0. Okay, a is positive, and sine or cos bx. Okay, sine or cos bx. So since sine or cos anything is less than or equal to -1, we'll get minus e to the power minus ax over here. And since sine or cos of anything is less than or equal to 1, we'll get exponential of e to the power minus ax over here. Alright? Okay. Now let's take r to be greater than 0. Any positive number. Okay? Any positive number. Then these are really nice functions, so we can integrate them, and by monotonic property of Riemann integrals, what we get is minus equation of 0 to r e to the power minus ax dx is less than or equal to integration of 0 to r exponential of ax, either sine or cos bx dx is less than or equal to integration of 0 to r exponential of minus ax dx. Okay? Okay. Now, let's see. Let's evaluate this integral. Let's evaluate this integral. What do we get? Integration of 0 to r exponential of a to the power e to the power a minus ax dx is equal to e to the power minus ax over minus a 0 to r. This is equal to exponential of ar over minus a plus exponential e to the power 0 means 1, so 1 by a. Okay, so this is what we get. Now, taking limits as r tends to infinity, in this integral, we'll get something like this. Okay, we'll get something like this. And since a is greater than 0, this limit will be equal to 0. And hence, limit r tends to infinity, this is equal to 1 by a. So, if we use the Squeeze theorem and take limits as r tends to infinity, in this inequality, what do we get? We get, since this is 1 by a, so negative of 1 by a, okay? Minus 1 by a is less than or equal to limit r tends to infinity 0 to r exponential of ax sine or cos bx dx. Okay, sine or cos is less than or equal to 1 by a. Now, this shows that the limit, this limit is finite, because minus 1 by a is also finite and 1 by a is also finite. Hence, we can say, since this limit exists, we can say that the given integrals are convergent. That is to say, integration of 0 to infinity exponential of minus ax sine or cos this into these the integrals represented by this notation are convergent, means these two integrals are convergent. So it is possible to find, or should I say it's possible to evaluate these improper integrals. Now, we're done with the first part. The convergence part is over. Now, let's say this integral is I and that this integral is j. Okay, I and j. Now let's use integration by parts. Integration by parts. Then what we get is I is equal to, integrate this by parts. Okay, okay. Yeah. Let me use two different colors for this. Okay. Okay. Let's take this function as the second function. This function as the first function. We'll differentiate the first function and integrate the second function in the formula. Okay. All right. So by integration by parts, using integration by parts, what do we get? First function into the integral of second function. Integral of second function is exponential of minus ax over minus a. Okay. Minus integration of 0 to infinity. The limits are 0 to infinity over here. Okay. 0 to infinity. Derivative of first function means derivative of sine bx means b cos bx. Okay, b cos bx. And the integral of second function means exponential of minus ax over minus a, and so this minus and this minus gives us plus over here. Plus over here. All right. So this is it. Now let's see. Taking limits as x tends to infinity, this limit will be 0. Okay, we know that. Limit x tends to infinity, exponential of ax, sine bx or cos bx, not matter, is equal to 0. This is a standard result. Okay, so when we take x tends to infinity, the first part, okay, it's like this. Limit x tends to infinity, sine bx, exponential of ax over a. Okay, let's use capital X, x to 0. We evaluate this part and take x tends to infinity. So when x tends to infinity, we'll get sine bx, exponential of ax over minus a to be 0 as x tends to infinity. And when x is equal to 0, since sine 0 is 0, the other term will also be 0. So basically, this whole term is 0. This whole term is 0. Okay? This whole term is 0. And so, what we are left with is, this is b by a. And if we look at this integral, it's j. Okay, it's j. So what we've obtained is I is equal to b by a times j. Let's call this equation 1. Now let's do the same thing for the second integral, j. We again integrate it by parts. Again, exponential function will be taken as the second function, and trigonometric function will be taken as the first function. Okay? So, first function times the integration of the second function minus integration of 0 to infinity derivative of first function. Derivative of first function means minus b sine bx minus b sine bx, okay, minus b sine bx, and integral of the second function means, integration of the second function means minus ax over minus a. So there are three minuses, that's why this minus sign will be retained, unlike in the first case. Okay? Alright. Dx. Now, as in the first part, as in the first case, the first term, okay, x tends to infinity, taking x tends to infinity, the first term will be 0. The other term will not be 0, however, because exponential of 0 is equal to 1 and cos of 0 is also equal to 1, and we will be left with minus 1 over of minus a, okay, evaluated at this function, evaluated at x equal to 0, okay, and minus b by a, and this is I. This integral is I, so b by a, I, which is nothing but 1 by a minus b by a, I. Okay, so what we have obtained is j is equal to 1 by a minus b by a times I. Now, let's see. I means b over a times j. So, we can write 1 by a minus b by a times b by a j. Okay? So, what we get is 1 plus b square a square, b square a square j is equal to, we will be left with 1 by a over here, okay, 1 by a. Now this will be equal to j times, this is a square plus b square by a square, okay, this will be a square plus b square over a square, j is equal to 1 by a. This a will be cancelled, we'll cancel one of the a's to give j is equal to a over a square plus b square. Alright? And if we use this value of j in 1, okay, if we use this value of j in 1, we get I is equal to b by a times a over a square plus b square, which is equal to b by a squared plus b squared. Alright. So, we've obtained 0 to infinity exponential of ax sine bx dx, because I is equal to this integral to be b over a square plus b square, and since j is equal to this integral, we've obtained 0 to infinity exponential of ax cos bx dx is equal to a over a square plus b square. Okay? Wow! This is the easiest, by far the easiest way I've found to evaluate these two integrals, okay? It saves a lot of time. It might have taken a lot of time in the video because I'm explaining stuff. If you are to do it by yourself, it'll take much less time than evaluating these two integrals separately, okay?